Hello everyone, my name is Hashit Tanvir. I am from Wuhan University, and today we are going to talk about mapping water bodies in Sentinel-1 and Sentinel-2 imagery. And we are going to use Snap, which is a Sentinel application platform, basically and especially for Sentinel products. All right, so before going forward, I want to say that I will not explain about these products like Sentinel-1 or Sentinel-2 in details, because we have already covered these things before in our previous lectures. Like we have done 4 to 5 lectures, and we discussed these things in detail. So I will keep it very brief in terms of the product descriptions. So for our study area, we have chosen a Missourian Lake District, which is in Poland, and this district has more than 2,000 lakes. So it is one of the best places to do our analysis in terms of finding water bodies. All right, so the first product we will use is the Sentinel-1. And we know that Sentinel-1 is an active sensor C-band, and it has a very short revisit time, and it can provide data both in day and night and in all weathers. And we will use IW swath in our data today. And for Sentinel-2, it provides for Sentinel-1, it provides radar data, or synthetic aperture radar data. And for Sentinel-2, we will have optical data with several bands in it. And to describe more about the bands, in Sentinel-2, we have mostly 13 bands, and including 8 B8A and B8. So collecting all becomes 13 bands. So there are different resolutions in Sentinel-2 bands, but the native resolution of the data is 10 meters. So depending on the different band, the resolution is different. All right. And now we will start the optical data processing first in Snap. So I showed this Snap before in the previous lectures. This is how the Snap looks like. And when we upload the data, it will appear here. And then we will use the data for our further processing. So first we will just visualize the data. I have taken the screenshot so that you can see every step easily. And when you click on this data, the arrow, and further down, you can see multiple things in Sentinel-2 data. Like there are many bands, there are many vector data, and there's also, right now you can see here, there are 13 bands showing in this data. And we also see multiple masks in it, which are, already inside the data, but I will tell you later why we try not to use those bands, which has several reasons, but they are already present in this data. Like you can see that water mask, vegetation, cloud shadow, and many other types of masks. All right, so let's try to show our data in RGB mode. You just need to right click on the product, and then click on the RGB image window, and here we will have an option to choose which band we want to use. And in this case we will use the false color at this time, since mostly the bands have different resolutions, so we will have less options, but later we will change these bands into similar resolution, and then we will have more options to see through. But right now we have limited options in terms of similar bands. So at this moment we will use the false color, and it will look like this. And right now this is a very huge area, and we will later subset it to the smaller area of interest, so that we can understand our data and interpret it easily. And the bigger the data, the more processing time it will take. So yeah, it depends on your machine also how fast it is in order to process the data. So here we can see how it looks like in RGB, and this is how it will look like when we, as I said, that we have different masks. So I show here the water masks where the white color is showing where the water is. So clearly we can see that the classification is not accurate. Like according to the classification, the white parts are showing the water bodies, while the darker areas showing the other areas. So here we can see that the classification is not very accurate. Let's zoom it up, and we can see that here, I hope you can see that the red circle is moving. This is a urban area which is classified into water. So that is why we try not to use this this mask, and we will do our own classification, which will be more accurate. All right, so before we do anything else, we, as I said, when we want to see the data, we had limited options before, because the resolution was not in the same. The resolution was not same for multiple bands. So now what we want to do, we want to keep the resolution in the same. We want to keep the resolution same so that we can perform different analysis. So how we can do that is by resampling. So there is a method in Snap. You just click on the raster, go to the geometric operations, and then click on resampling. And when you click on resampling, you will have this window. So there are three methods to resample: by reference band, or by target width and height, and by pixels. So in this case, we will use the band for the reference. There are multiple bands here, but we will use B2 band because it's originally 10 meters, so that we will use as a reference band. So once you select the band, but you can choose other options based on your choice, and I choose this reference because it's more it is more like I find it more good for this kind of process, to use a reference band so that I can use one band for all the others. All right, so once you run this, and you will see there is a new product here appear in the product explorer. So this is the product. When we open it, we want to see it as a RGB band, RGB channels, and now we see that there are many options for us. Like we can see false color infrared, we can see false color urban, agriculture, and healthy vegetation, automatic penetration, and many more. But for us, we are interested in water, so I selected the water one, and then I will click OK. All right, and once I click OK, then I will have to choose the bands. In this case, I will choose the infrared, near infrared, short infrared, and red band, which is better for the presentation of water. Once I click it, I will see this this image, which is showing different classifications. But this is, as I said, it's a very big product, so it will take a lot of time to process. So we want to subset it to a smaller area. So basically, how do you subset it? You click on the raster, and then there's the first option to subset. So there are three types of subsetting: spatial, band, and metadata. We will use the spatial subset. It's easy, and we will select our area of interest. You can use it by just moving the cursor from here, or you can add your coordinates, and you can also add the specific coordinates, like where you want to start and where you want to end. So there are two options here. One is pixel coordinates, and the other one is geo coordinates. So if we're using one product, pixel coordinate is the best option. But if we are using multiple multiple images, sorry, then the better option is the geo coordinates, so that we can extract the same area in multiple images. Right, when you subset this area, you just click it and and then you will have your area of interest. Right, so before going to the area, I want to I'll explain a little bit the normalized difference water index NDWI, because we want to perform this in order to extract water from water bodies from this image. So what we do is, like, first we will see the reflectance values here, because as we can see here in the near infrared, the water reflectance is none. So we all the signals will be absorbed, and we will see a dark areas wherever the water is. However, in the visible, there is water has more reflection. So what we do is we will subtract the B3 band from B8 and then divide it by B3 plus B8. So at the end, in the result, we will see that the areas where the reflectance value is less than 0 will be considered as land, which will be the darker areas, and the areas where the reflectance value is higher than 0, that will be considered as water, which will appear as white in the resultant image. All right, so let's see how can we perform that in Snap. So first we see that here we have to use two bands, B3 and B8. So first we will open those B3 and B8 bands here. As you can see, I have opened here. B3 band will look like this. However, B8 is an infrared band, so here we can see the water bodies are very clear. And then we will perform this computation using a function called bandmath in Snap. So you just need to select the product and then right click on it and then click the bandmath here. So once you click it, there will be a window popped up here where you can write your expressions. So the mathematical expression, we have written it here. There are numbers written on the bands, and you can simply click on it and then you can write your expression. You can write it by your own, or you can write it automatically also. So once we have finished our expression, we will click OK, and there will be a new product, and it will look like this. So here we can interpret that the white bodies are water and the darker bodies are land or something else. We don't care at the moment what are these, because we are just focusing on the water. At this point, this looks like a bit of noise in the darker areas. We want our water bodies to be very prominent, so we can apply a bandmath again. We can transfer it to the let's say binary, so that we can clearly define the white areas and darker areas. So again, we will click on the bandmath, and then I wrote if this NWDI, which we have extracted before, is greater than 0, then if it's greater than 0, then put it 1, and else it should be 0, which means that, let's see on this histogram here. So all the darker areas are on this side, but we are interested in the white areas, this white peak here, so which are all the positive numbers. All the negative numbers are on the other side. So this expression means that if the value is higher than 0, then keep it white, otherwise make it black. So this will transfer our image to binary, and the result will somehow look like this. And this is much more clearer than before. Like you can see here, before the bandmath, before the binary, it was like this, and now it looks like this. It is more prominent. So now keep in mind that keep saving your products. Snap generally save it in the Snap memory, but once you close it, all the data will be gone. So you have to physically save it, and after saving it, you can export it from the files, and then there's an option for export. You can export it into the GeoTIFF, because we will use that for comparison later in QGIS. All right, so we are done until here for the Sentinel-2 data, and now we will perform the Sentinel-1 processing. All right, so in the Sentinel processing, I've used 5 products, and the Sentinel product will look like this. The footprint is larger, and it looks like upside down because of the geometric correction is not done yet, right? So this is how the Sentinel-1 data will look like, right? So first we have to pre-process the data, but there are 5 images right now here. So if we do the pre-processing one by one, it will take time. So there is a very good, very effective thing in Snap which is called batch processing, and we can just build a graph to for each of the image, and we will do it automatically for the rest of them. So for the processing, we will make a graph. This is the graph I made. Like, first you read the product, and then you will do the subset according to the same one and the same coordinates from the Sentinel-2, and then we will apply the orbit file, then we will apply the thermal noise correction, and then we will do the calibration, terrain correction, and then at the end we will get our resulted image. We have done this before in our Sentinel-1 processing, before in the previous lectures. All right, so first off, and then we will open the batch processing. After this, this is the graph builder, and after in the tools there is a batch processing. So I will show you how it will happen in the batch processing. So no need to change any settings here unless it can create some problems. We will do that in the batch processing later. All right, so in the batch processing, when you open it, it will look empty. So you have to click on this option below the first one here, the second one, and all the images or products will appear here. And then just click on the refresh button here, this one, and it will rearrange it accordingly based on the time and date. So if again you see, excuse me, okay. But if again you see that the arrangement is irregular, you can click on it, and using this up and down options, you can change the arrangement based on their time and date. Right. So once we've done this, we will save this product, and we will we will upload the graph that we have saved here. We have saved this graph so that we can upload it into the batch processing, and that will apply on all the products that are here. All right, then we will upload the graph from here, and then once we are done, then we will start the other things like subset, apply the orbits, all the things that are written here we will apply now in this batch processing here. So first is the subset, and then in the subset there is an option here, this blank area, where you can add the coordinates which we have taken from the same subset of the Sentinel-2, so that we can match our our areas of interest. So once you add those coordinates and click the update, you will see that this yellow yellow rectangular box will appear, which is our area of interest, and the red is our full image, which we don't need. It's a very big image, and it will take a lot of time for processing. So we have taken our subset according to the Sentinel-2, so we'll process this one. Then we will apply the orbit file, keep it same as it is, same for the thermal and noise removal, and also is same for the calibration. Keep the settings as a default, And for the terrain correction, if you have your digital elevation model, you can use that one. Otherwise, you can use the one that is here already. And you can also you have to change the map projection. Right now it's WGS, but normally the Sentinel-2 is in UTM, so you can check that and change that accordingly by clicking here in the map projection. All right, so once we complete, we will run, and this will be our product. Right, so and now after this we will do co-registration. And why we do co-registration, that is the reason why I used 5 products here. I forgot to tell you before that why I used 5 products for Sentinel. The biggest reason is in the Sentinel products, we have this noise, which we call speckle noise. And there is an option here in Snap to remove the speckle noise, but when we remove the speckle noise, we lose the resolution. It degrades the image. So the best way is to do the co-registration, and at the end we will get a much more better image. And I will show you right now here how it's done. So when we do the co-registration, it will look like a batch processing, but it is different. However, the outlook is similar. So for this purpose, we have multiple options. Like in the create stack mode, we will use a master product, which can be found at this find optimal master. You just click it, and this software will automatically find the optimal master image for you, which we need in co-registration, because we need a master image so that we can relate all the pixels based on that master image. And resampling type, there will be multiple resampling type, but I use the nearest neighbor one. You can change it based on your requirement, but this one, I choose this one. And for the cross correlation, you don't need to change anything. Just keep it as default, and then just click OK. And now we will have different bands for each of we will have different bands for each of the product. Right. So before going forward to that, I just want to show how we can use this as a change detection also. So this is very interesting. So once you co-registered all the images together and you open it as an RGB, so you see the colors here. This has nothing to do with our water body. It was just interesting, so I put it there. All the colors are showing the change, and the other parts which are not changing are not showing any colors. For example, this water and this urban area, there are no significant changes. However, on the upper parts where we have vegetation, we can see a lot of changes. So this is how we can use it as a change detection process. But this is not related to our water bodies. I just put it there just for some extra information. All right, so now we have to do the stack averaging so that we can get a single product out of all the other 5 that we have co-registered. So the stack averaging, when we all right, stack averaging, yes, it will be in raster, so you can check it, or it's in radar. I forgot which option was it, but it's in radar, I guess. Yes, so you can do the stack averaging from the radar option. All right, so once we do that, we will get a single product like here, which is called a sigma naught VH, and this is the final product, final average product. Now we will see a bit of difference what we have in this averaged one and the other ones. All right, so I did a multi-window multi-window look where we can see this single the other ones, like here, this one, and this one. These are before the averaging. These are single images, And the last one here in the right corner is the co-registered, the averaged one, the stack average image. And here we can see that the shoreline is well defined, and we can see that the vegetation, and we can also see the other parts. However, in the other three images, there is a lot of speckle noise, and it's very difficult to understand what is in those areas. So that was the reason why I used these five images instead of doing the speckle noise removal. If you do the speckle noise, it is also okay, but keep in mind that it will degrade your image quality. All right, so now we have these two images, like in VH and VHDB. Why we did this DB is like we have done the linear transformation. So once you right click on the product of sigma naught VH, which is look like this in the upper part of this window, right click it and then transform into the linear transformation, and then you will receive the resultant image will look like this, which can help us in better understanding of the water bodies. So we will apply a band math on here so that we can extract the water bodies from here also. All right, so again, we right click on this one and then apply the band mask, and based on our histogram here, we will check that if the values are less than minus 25, then it is 1, else show it as 0. All right, so once we hit OK, the final product will be like this, right? So here we can see that the white areas are showing us the water bodies, and it is also almost look like a binary image. It is a binary image, right? And it's easy for us to interpret the water bodies here. All right, and keep in mind that keep saving your work, because as I said, once you close Snap, all your data will be lost, and you have to you have to save them in GeoTIFF so that we can later use that in QGIS or ArcGIS for the comparison. Right. So at this point, we will do the subset so that we can have the same geographical coordinates, geocoordinates as in the Sentinel-2. So I will open the subset area, and then I will put the coordinates that I have saved from the polygon of Sentinel-2, and then I will add them here, and then click OK, and then I will have that product, and I will save that in GeoTIFF for the further analysis, and then I will import both of these GeoTIFF files into the QGIS here, right, in the analysis. Okay, so I have opened that both of these both of the resultant images in QGIS. So, and you can use the properties to to remove the other areas, like here you can remove the black ones, and you just use some color combination to keep the water bodies here. Do the same for both Sentinel-1 and Sentinel-2. Right, so we will import a background map so that we can see that which areas have water and which areas don't, and we'll see how the results for both Sentinel and Sentinel-2 look like. Okay, so I have overlapped the results, and we can see that Sentinel-1 has some areas which are not found in Sentinel-2. Right, and when we look at here, we can see that here in some areas, this one, and this third one, these are the water bodies that are identified by Sentinel-1, which were not very visible in Sentinel-2. So that is the advantage of Sentinel-1. we have. On the other hand, if we look a bit more closely, Sentinel-2 has identified the water bodies more than Sentinel-1. Like these red areas is going a bit out of the range or the limit line of Sentinel-1, means that it has extracted more water near the shorelines. So that is because Sentinel-2 has higher resolution. Right. So this is the difference between Sentinel-1 and Sentinel-2. But in my case, I would consider Sentinel-1 because that can identify even smaller parts of water bodies. However, if you want to use the optical ones,